Hi, I'm Aaron Kennedy. I'm a senior technical support engineer with Tuxera. We're a data management software company headquartered in Helsinki, Finland, and we have offices all over the globe, including North America, Asia, and throughout Europe. Today, I'm going to be discussing enterprise software solution that we offer for file sharing that solves some challenges that you may be facing in terms of failover, scalability, or performance bottlenecks. The solution that we'll be discussing is an SMB file server. It's especially fast and reliable for media and entertainment content creation, and it has a lot of other uses in the enterprise environment. The name of the file server is Fusion File Share, and it's by Tuxera. We're going to be addressing 3 questions today in evaluating high-performance enterprise-grade SMB implementations. The first question to answer is, what is the dominant operating system for backend storage? I'll give you a guess. It's not Windows. And second, we'll be asking, what are some important considerations for high performance workloads? When you're consuming data, what are some of the features that you should be shopping for? And then finally, and perhaps most importantly, just how fast is it? Let's look at some real world numbers to see what's possible. So the storage industry over the course of my career has moved from NAS and SAN devices to what is now called software-defined storage. Certainly NAS devices are still in the environment, SAN not so much, but the architecture of how storage is provided has changed over time. Increasingly, it's software-defined, whether it's on-premise or in the cloud. And the operating system of choice for software-defined storage is Linux. Here in the diagram, we can see the architectural difference between NAS and SAN devices and software-defined storage. For a NAS or a SAN, you have a storage controller, which controls a whole array of disks. And if you want to increase your storage as your business grows, you scale up. So you can either put more disks in your array, or you can simply buy a much larger system. That has changed with software-defined storage. Most notably, the storage controller is now separated into a control plane and a data plane. By separating these two things into separate logical software components, the data plane now controls the disks. And those disks are really on commodity hardware servers. So you can just rack and stack another server into your data center, and you can essentially scale out. And so with each additional server that you add, you're not only adding disks, but you're also adding CPU and memory resources. And this is largely the difference between scale up and scale out. So if your storage is Linux, can your file server be Linux too? Well, yes, it can. Fusion File Server as an SMB implementation can run directly on the same Linux host participating in your software-defined storage cluster. And it can provide SMB file services to both Mac and Windows clients. So there's no need to consume your storage with several layers of virtualization or a Windows front end accessing your storage. You can read and write your data directly to the storage cluster itself, and there are real advantages to having that direct access. Fusion File Share additionally integrates with the Windows domain and Active Directory, so you can use all the familiar tools and workflows to manage your shares and administer access controls. So if your high-performance workloads require a fast file server, what should you be shopping for in terms of feature set? Well, let's go through a few of those. You should certainly have multi-channel. You may very well, especially in the media and entertainment space, want RDMA, also known as SMB Direct. You will want scale-out clustering. You'll want low latency, and you'll want throughput. Let's look at each of these in turn. For multi-channel, SMB multi-channel creates multiple connections for a single SMB session between client and server. This allows for increased throughput by utilizing multiple TCP connections, either through a single adapter or multiple adapters. But perhaps even more importantly, it prevents CPU bottleneck. This is a really important benefit, especially for workloads with many small I/O operations. Receiver-side scaling network adapters allow SMB multi-channel to assign each of these TCP connections to a separate core. So you're load balancing across the available CPU resource. This prevents bottlenecking that can be caused by a single TCP connection for the entire workload, consuming a single core and leading to congestion. Another feature you will probably want to look at, especially in the media and entertainment space, is RDMA, Remote Direct Memory Access, also called SMB Direct. RDMA bypasses the TCP stack, and it allows for remote direct memory access, just like the acronym says, between the client and server. This gives you high throughput, low latency, and also low CPU utilization because there's not a lot of context switching as you move down the network stack. Fusion File Share by Tuxera is the first to market with SMB Direct on Linux. And we're seeing our media and entertainment customers having just a huge benefit from the low latency, especially in post-production work with playback. Another thing that you should be shopping for is being able to scale out with your cluster. If you remember the previous slide with software-defined storage, we're now scaling out instead of scaling up. So we're adding additional nodes to our cluster, and you want your SMB solution to do the same thing. Fusion File Share offers 3 essential modes for deployment. One you can see on the left, standalone. It's very simple to understand. It's just a single instance of Fusion serving clients. The second is Fusion in an active passive mode. This is 2 instances of Fusion, only one of which is active, and the other is serving essentially as a hot spare, ready to take over in case the first active instance fails for some reason. And then finally, we have what we call active-active. So this is multiple instances of Fusion concurrently serving in parallel multiple clients. And when you add that new server to your rack and scale out your storage cluster, you'll just add a new instance of Fusion on that same host and scale out in parallel with your cluster. We offer Fusion with CoreSync and Pacemaker as open source solutions to manage the cluster, but we can certainly integrate with any messaging layer or cluster resource management software that you use. Another thing that you should be considering is latency. We had a customer use case that was concurrently opening, reading, and closing 3 frames, which were comprised of 38 megabyte files, and we needed to do that in under 16 milliseconds. There was a cache of frames that was maintained to allow us to complete this operation in no more than 16 milliseconds. The frames are delivered more than 16 milliseconds. Of course, the application then reaches into the cache, and the cache would drop by 1 and hopefully recover. The cache depletes if the latency of the 3 video playback layers is too high, and of course the result is a dropped frame. Our customer ran Fusion for 24 hours, and the requirement was to not drop a single frame. And I'm happy to say that we passed. In the media and entertainment space, a common benchmark tool that is used is frame test. And this graph shows Fusion File Share compared to an open source alternative. We can see in the first graph the frame transfers in milliseconds. And you can see that Fusion achieves a number of frame transfers per second as the threads increase. Whereas the open source alternative, you can see that the time increases as the threads increase. Below, you can see that this high frame test still provided very good throughput. Fusion was able to scale with the red bar with the number of threads, throughput increased, whereas the open source alternative throughput essentially remained flat. And the frames per second also increased as we scaled the number of threads for Fusion. And finally, what is the most important thing? Well, it's throughput. Everybody wants to know how much data they can move and how quickly. Fusion's implementation of the SMB protocol is near storage speed of the backend storage. What does this mean? Well, here we can see a single client testing Fusion on the world's fastest parallel file system. And what this graph shows is that Fusion is able to achieve approximately 85% of what the local file system can achieve. So if you look at the graph, the dark blue line is the local file system. So that's an FIO benchmark done on the storage host itself. The red graph is Fusion File Share run on a Windows client over the network. And you can see that Fusion File Share adds very little overhead to the local file system's storage speed. And finally, the blue bar is the open source alternative, which you can see doesn't really compare in terms of the amount of overhead it's adding to the overall performance. So Fusion File Share by Tuxera is really an advanced SMB file sharing for media applications running on your Linux software-defined storage. I encourage you to check out our website at tuxera.com and reach out to us at our sales team. We can certainly get you started with an evaluation and work with you directly so that you can see what the solution offers. Thanks for your time. Bye.